Applications of differentiation. Is a curve increasing or decreasing? Find the interval for which the function f of x, which is a cubic function, is increasing or decreasing. Positive cubic functions have this sort of shape. It has a maximum and a local minimum. Increasing means as x increases, so does the y increase, the output increases. This means as you move towards the right, the curve is rising. These are the increasing areas. And decreasing is the opposite. As x gets bigger, y gets smaller. So this is the decreasing section of this curve. It would be interesting for us to know where the local maximum and minimum are, because then we can identify where this change happens. At the maximum and minimum, the derivative is 0 because the slope is 0. So we differentiate the cubic by multiplying by the power for each term and reducing the power by 1. This creates the quadratic 3x squared minus 6x minus 9. We want to solve this when x equals 0, because that's where the turning points have the slope of 0. We see 3 is a common factor here, so dividing across by 3 makes this a simpler quadratic with the same solutions. And the factors for this are x minus 3 and x plus 1, giving factors x equals 3 and x equals negative 1. Now we know the solution to the problem already then, because we understand the shape of the curve. We know the maximum happens when x equals negative 1, because the maximum happens before the minimum. We see it from the picture, and the minimum is x equals 3. It might not always be as simple as a cubic function that we'd recognize. Formally, how we understand this is that the derivative is positive when it's increasing. The rate of change is positive. So when is this quadratic positive? Well, if we drew a sketch of the quadratic, as one way of doing it, we could do a zero test as well, but if we draw a sketch of a quadratic and imagine it crosses the x-axis at the points negative 1 and 3, and we're asking when is this above the line, when is the function positive? And looking at the picture, we see it's positive when x is less than negative 1 or greater than 3. So this is when the function is increasing, for values of x smaller than negative 1 and x greater than 3. So we'd write the inequality like this. So that's increasing. Let's go back and just shade it in on the curve here. So it's increasing values of x above 3 and below negative 1. So it must be decreasing at those inside values, the unshaded region there. So technically decreasing means that the slope is negative. The slope is less than 0. That's what decreasing means. And it doesn't include the turning points, because that's where it equals 0. So it's less than 0 on those inside values. X is between negative 1 and 3. Might just shade that in there. And we can relate this back to our original curve as well. So it doesn't include the turning points, but at values below negative 1, we can see it's increasing. It's also true for values above 3. And inside that region, we can see that's where it's decreasing.